name is Fritz Wiki. I was born February 14th, 1898, in Bulgaria. I shortly then moved, at the age of 6, with my grandparents to Switzerland, where I studied math and physics at the Switzerland Institute of Technology. In 1925, I moved to the United States, where I worked with Robert Milken at the California Institute of Technology, and I've made several important astronomical discoveries. Dark matter. In 1933, while looking at the Coma Galaxy Cluster, I came up with a theory of dark matter. I was the laughing stock at the local bars along my fellow astronomers. Those scatterbrains, they doctor their observational data to hide their shortcomings and make a majority of astronomers accept and believe most of their prejudicial and erroneous presentations of interpretations of facts. But 40 years later, when the study of motions of stars and galaxies was finally theorized, I was finally taken seriously.
Spinning faster than they should be according to their math.
Every galaxy rotates around a center cluster of objects, and this cluster was previously believed to hold the greatest amount of mass based on the orbit of all the celestial objects within the galaxy itself. Now, according to the laws of physics, the total amount of mass in a galaxy is directly related to the speed of its rotation. So, the more matter contained within one area, the faster the speed of rotation must be in order to hold everything together. This would be like putting a tennis ball on the end of a string and swinging it around your head. And pretend that the tennis ball represents all matter in galaxies. Now let's consider a galaxy with more mass, galaxy B. If you were spinning an object with more mass, like a kickball, you would have to move it considerably faster in order to maintain a constant rotation. However, it has been proven that galaxies are rotating at, in some cases, up to 10 times faster than what is predicted based on the visible matter within them. This has called into question the amount of matter really contained in our universe. Dark matter explains what has become known as the missing mass in our universe. Dark matter is something that cannot be seen or touched. In fact, scientists don't even know exactly what makes up dark matter. The only reason we know that it exists is because we can observe its gravitational effects on celestial objects.
Why is there a redshift of faraway celestial objects?
In previous theories, the universe was thought of as nothing more than a bubble, which remained a constant size. Yes, it was growing, but that growth was slowing down and would eventually stop. Wrong. You see, the farther an object gets from the center of a galaxy, which is theoretically composed of the most mass, the slower it will move. Imagine the tennis ball as being any random celestial object. The longer the string, the slower it will need to rotate in order to make it. However, scientists have found that the farthest celestial objects within any given galaxy, and within the universe as a whole, are actually accelerating and spreading apart as opposed to maintaining a consistent distance. This means that a stronger gravitational force must exist elsewhere to explain why these objects are moving away from the gravitational force giving off from the center or most massive area of the galaxy. This is the gravitational force exerted by dark matter. Observe.
I'm a celestial object. You're a star in my heart. Do you know what my favorite brand of gum is, Phil? I have no idea, Dexter. It's Orbit. Do you know what my favorite cleaning supply is? Is it Comet? You nailed it.
Dark
I love
matter.
orbiting. Orbiting is great. Oh man,
What's wrong with me?
Hey man,
Dark
what's
matter.
up? Why did you stop orbiting?
I don't matter
You totally
anymore.
stopped orbiting.
Ah!
Again, this explains the redshifts being observed by distant celestial objects.
Why is this discovery so important to the world of astronomy and physics?
Well, we know that the universe is expanding at such a rate that it could result in a premature death of our universe. But that's no fun to think about. Besides, physicists now believe that the universe might actually bud off to create a whole new universe. NASA is even sending up a satellite called LISA, which stands for Laser Interferometer Space Antenna, in 2011, which will be able to give us a picture, so to speak, of the genesis of our universe. And what will they be studying to give us this data? Black holes. Picture the bubble again. As it is expanding, it is kind of giving birth to another bubble. So it will expand and eventually fission off to create two bubbles, with black holes as the umbilical cord between those two universes. Dark matter has thereby introduced the idea of the multiverse into physics and astronomy. So, at the risk of repeating myself, why was this discovery of dark matter so important? Aside from explaining the phenomena discussed previously, it has revived interest in black holes, introduced the concept of what is becoming known as white holes, and has redefined the term universe altogether. How's that for discovery?
You can help the FBI bring down the toughest white-collar criminals. You're with the FBI?